Hi, today we're going to solve the 1 marks question from engineering mechanics from question number 1 to question number 10. Let us start. The first question. The figure shows an idealist plane truss if a horizontal force of 300 Newton is applied at point A. You can see there is a horizontal force of 300 Newton acting on point A. Then a magnitude of force produced in a member CD is. The concept that we are going to use here is if three members meet at a point, at a joint, if three members meet at a joint and two of them are collinear, then the force in the third member is 0. So you can see if we consider joint B, you can see there are three members meeting at joint B. Member 1, member 2 and member 3. And clearly you can see two of them are collinear. Collinear means they're along the same straight line. 1 and 2 are collinear. So definitely what will be the force in member 3, that is BC. The force in BC, I can say it is equal to 0. The force in member 3, that is equal to BC, is equal to 0. Similarly, now if force in BC is 0, what I can say, I can simply neglect this member BC. I can simply remove it from the truss, right, while for calculating purpose, because it is not taking any load, it is not supporting, it is not doing anything, right, for this member. So if you remove this member BC, now if you concentrate on joint C, you'll get to see again at joint C there are three members meeting, member 1, member 2 and member 3, and of these three members, two of them are collinear, AC and DCE, that is 1 and 2 are collinear. So if at a joint there are three members meeting and two of them are collinear, the force in the third member is 0. So I can simply say the force in member CD is equal to 0. So this is your required answer. This is your required answer. Force in CD is 0. Okay, let us move ahead. Okay, question number 2. A block of 10 kg rests on a horizontal floor. The acceleration due to gravity is 9.81. The coefficient of static friction is 0.2. A horizontal force of 10 Newton is applied on the block as shown in the figure. The magnitude of force of friction on the block is. Now the friction force, that is, I'm assuming that the block is static, it is not moving. It is not moving, right? Because it is the coefficient of static friction that has been given in the equation. So now all of us must understand this point first, that static friction is a self-adjusting friction, and the value of static friction, the magnitude of static friction, it varies from 0, minimum of 0 when there is no force, no external force, to a maximum value of mu s into n, where mu s is the coefficient of static friction and n is the normal reaction. Now let us try to find out what is the maximum value of static friction in this block. So let me draw the FBD and try to find out what is n. So it's not required to draw the FBD separately every time, because we know we are solving a multiple choice questions, so nobody is going to see our answers, right? Means final answer will be seen definitely how you the process you have solved. There's no marks on that. So still okay, for your understanding I'm drawing it separately. And so there is a force F and there will be a static friction force, let me say Fs. So clearly you can see N is equal to mg, that is m is given as 10, g is 9.81, so this is equal to 98.1 Newton. So if you see what will be the range of Fs now, Fs will vary from 0 to a maximum value of mu s into n, 0.2 into n is 98.1. So the value of Fs, maximum value of Fs will be 0.2 into 98.1, 0.2 into 98.1. So this is equal to 19.62. 19.62. Okay, I advise all of you to use gate calculator, right? The online calculator. I'll show you a glimpse of gate calculator. I'm not using it because it disturbs my uh, recording process. So that is why gate calculator So if you see, this is the first one by TCS iron is the best. So you can definitely do it here. 0.2 into 98.1. So sorry, 0.2 into 98, sorry, into 98.1. So all of you should have good practice over this calculator if you really want to do get gate, because otherwise a lot of time will be consumed in doing it through this. So till gate, just leave this calculator aside, right? So this is how you have to do it. This is how you have to practice. Okay, I'm not using this on screen because it disturbs my recording process. That's why I'm using the physical calculator, and I'm not going to appear for gate. Okay, so the static friction varies from 0 to 19.62. As I said, static friction is a self-adjusting friction. It will only act that much how much is required. Now here the external force, if you see, the external force is 10 Newton. External force is 10 Newton. So to balance a external force of 10 Newton, how much will be the static force? Static friction force will also be is equal to 10 Newton. Right? Now, what is the meaning of this 19.62? Means I can increase this force to 19.62, and the static force, friction force will also increase from, can increase from 10 to 19.62, right? And the block will remain at rest. But if I apply a external force greater than 19.62, it may, the static friction will not be able to increase beyond this point. So there will be net force towards right. So the block will start accelerating towards right. So the block will start moving towards right. Okay, I hope you got the answer. So the answer here is 10 Newton. The friction force that will be acting is 10 Newton. Okay, let us go to the third question. A ball is dropped from a rest from a height of 1 meter in a frictionless tube as shown in the figure. The tube profile is approximated by two straight lines. You can see there are two straight lines, one vertical and one horizontal. The total distance traveled by the ball is, okay, correct to two decimal places. Now, a very simple concept here. The concept that will be used here is, since the ball is frictionless, total energy will always be remain conserved. Total mechanical energy will remain conserved, right? Mechanical energy means sum of potential energy and kinetic energy, right? So initially kinetic energy was zero, right? Because it is clearly written that ball is dropped. Finally, also the kinetic energy will be zero. Why? Because the ball will go and stop there, right? The finally kinetic energy will be zero. So the potential energy at point 1 and point 2, potential energy at point 1 and potential energy at point 2 should be same. So if the potential energy should be same, the height from ground that the ball will rise will be 1 meter again. So I hope you're getting the concept. So the ball after dropping, doesn't matter if it is inclined, since there is no friction. So it will go to a total height from the ground. It will go to a total height of 1 meter. So we can easily calculate the total distance traveled here. Now this angle is 45 degree. You can see. So this will be 1 divided by cos of 45. If you consider the triangle, right? If you consider this triangle, you can consider this triangle. Sorry. If you consider this triangle, this is a right angle triangle, you can see, right? So the hypotenuse is 1 divided by cos, the base divided by cos of 45, right? So the total distance traveled, I can say the total distance traveled is 1 meter, just from here to here, this point, and plus 1 by cos 45. So cos 45 is root 2. So 1 plus 1, 1 by 1 by root 2, 1 plus, it will become 1 plus root 2 meter. Root 2 is 1.41, so it will become 2.41 meters. So the answer is 2.41 meters. Answer is 2.4. So I hope you got this. Let us move to the next question. Two disc A and B with identical mass m and radius r are initially at rest. Okay, they roll down from the top of identical inclined planes without slipping. Okay, they are rolling without slipping. Okay, pure rolling from the top of identical inclined planes means they are descending downwards from the same height. They're descending downwards from the same height. Okay, this A has all of its mass concentrated at a ring. So basically, this is a ring, not a disk exactly, because all the mass is concentrated at a ring. So what is the moment of inertia of A with respect to CZ? I can say it is equal to mr square, right? So moment of inertia of A about instantaneous center of rotation. All of you should know what is the instantaneous center of rotation, right? So if this is rolling, I'll show you the plane of rolling plane also. Let me say it is rolling around this plane, and this is this A. So what is the instantaneous center of rotation? Here's a point of contact, right? This is the ICOR. So this is equal to how much? How much will be the instantaneous center of rotation? I can say this is equal to, this is equal to, right, ICZ, that is mr square, plus mass into distance of CZ and the point about which you are calculating the moment of inertia, that is radius r. This radius r, mr square plus mr square. So this will become 2mr square. So this will become 2mr square. Okay. So similarly, if you consider B, so while the disk B has all its mass uniformly distributed, so if you want to calculate the moment of inertia of B, I am directly calculating about ICOR, instantaneous center of rotation. I am directly calculating about instantaneous center of rotation. I am directly calculating about instantaneous center of rotation. IB about instantaneous center of rotation. This is equal to about CZ. About CZ is equal to half mr square. About CZ is equal to half mr square plus mr square. That is equal to 3 by 2 mr square. Right. So moment of inertia of block A is disk A is 2 mr square, and moment of inertia of the disk B is 3 by 2 mr square. Okay. So what is the concept that needs to be applied here? Again, as it is said, they roll down from the top of same identical inclined planes, right? So they're coming down from the same height. So at the bottom, while they reach the bottom, the kinetic energy of both the disk will be seen. The kinetic energy, because the decrease in potential energy is same for both the disk, so the increase in kinetic energy will also be same for both the disk. So I can say the kinetic energy. So I can simply say, what I can say is the kinetic energy of A and B will be same. So kinetic energy of disk A is equal to kinetic energy of disk B. So what is the kinetic energy of disk A? I can say it is half IA omega square is equal to half IB omega square, omega A square by omega B square, sorry. Okay. So I know the value of IA and IB. So omega A by omega B. This can also be written as VA by VB. How? If I multiply the numerator with both the numerator with R, right? Just simply, if I'm writing it, multiplying it with R in the numerator and R in the denominator. So omega A into RA will become, because the radius of both the discs are same, right? Radius of both the discs are same. So I can write it as VA and VB, right? So this will be equal to, this is equal to, you can see IB IA root 2. So IB, what is IB? IB is nothing else but 3 by 2 mr square, and I is 2 mr square. So 3 by 2 mr square and 2 mr square. So answer is 3 by 4 root over 3 by 4 root over 3 by 4 root over 3 by 4. Okay, thank you. So I hope you got it. Right? The answer is root over 3 by. Okay, let us move on to the next question. Okay, this is a question, very simple question, but conceptual question. Question on FBD. If force F is acting on the band bar, which is clamped at one end as shown in the figure, the correct F free body diagram. It's very simple question, very interesting question. Now, Now as you can see here, now you can see here the force is in this direction. So the force will have two components, a component in the x direction and component in the y direction. So definitely there will be two reactions develop, a reaction in the x direction and reaction in the y direction, right? And apart from this, you can see the force is also producing a moment, right? Force is acting this way, the force is also producing a moment, so there will be also a moment. Sorry. I'm sorry, the force is also producing a moment, right? So if you see, the correct FBD will be A. So why I'm not choosing B? I'm not choosing. Okay, sorry. So I'm not choosing B. I'm not choosing B because in B, option B, the ground is shown, the environment is shown, and we all know that in FBD we should not show the environment. It is only the system and the forces that is acting on the system by the surrounding. We should not show the surrounding. Okay, so that is why option A is the correct answer. Okay, let us move on to question number 7. A point mass having mass m, a point mass having mass capital M is moving with velocity v at an angle theta to the wall as shown in the figure. The mass undergoes a perfectly elastic collision with smooth walls and rebounds. Okay, perfectly elastic collision. The total change in the momentum in the masses. Okay, clearly you should be able to understand that a collision is happening in the y direction. So the velocity that will change is only the velocity in y direction. Means the momentum will change only in y direction. So there will be no change in velocity or momentum in x direction. Clearly you can see all the options are of j cap. There is no I cap term, means there is no change in the momentum of in the x direction. And the paper in the gates are set in very such a nice way. They're saying the total change means final minus initial. They're already telling you in bracket. So what you have to find is final minus initial so that you don't get confused. Okay. So this velocity will have two components. This angle is theta. So if I resolve this velocity, it will have two components. This is v cos of theta, which this is I cap component, right? And this is v sine theta, that is j cap, right? So what is the initial momentum? Momentum initial, momentum initial, I can say this is equal to mass into v sine theta j cap, right? In the upward direction, right? In the upward. That's why positive g. This sign is positive because the velocity is in upward direction. Now after collision, since it is a perfectly elastic collision, the velocity with which the ball is approaching the wall after striking, the velocity will change the direction, but the magnitude of velocity will not change because if it is an elastic collision, the coefficient of restitution will be 1. Velocity of approach will be equal to velocity of separation, right? Ball is not moving, so the velocity of ball will remain constant. The magnitude will remain constant. The direction will simply reverse. So what is the final momentum? Can you say me what is the final momentum? Can I say it is equal to minus mv sine theta j cap? Why I've written minus? Because it is coming down and you can see the magnitude portion is constant. So if you want to find out total change in momentum, so this is already given in question, it should be equal to final momentum minus initial momentum. If you calculate it, it is coming out to be minus mv sine theta j cap. So the answer is D. Answer is D. Okay, let us move on to the next question. Question number 8. So this is again a very nice question, very simple question. Okay, a point mass m is released from rest and slides down a spherical ball from height h. Okay, it is coming down from a height h as shown in the figure. The surface of the ball is smooth, means there is no friction. The velocity of the mass at the bottom of the ball is the velocity of the mass when the mass reaches the bottom, right? Let me assume the velocity of the mass is. So what kind of motion? I can assume this is a translation motion. This is simply a translation. This is not rotation, my dear. This is simply a translation. Translation on a curved path. So what is the concept to be used here? The concept to be used here, you can see released. The mass is released from rest, right? So initially the kinetic energy was 0, right? So the decrease in kinetic energy, potential energy, the decrease in potential energy, I can say it is increase in kinetic energy. So the change in, I can simply say change in potential energy is equal to change in kinetic energy. So what is the decrease in kinetic energy? I can say mg capital H. So this is equal to increase in kinetic energy half mv square. So from here I can write v is equal to m, and m will get cancelled out. So this is equal to 2gs. Such a simple equation, right? 2gs. Option is C. Option is C. Okay, so let us see the next question. Question number 9. A rigid ball of 100 Newton is suspended with the help of a string. The ball is pulled by horizontal force F such that the string makes an angle of 30 degrees with the vertical. The magnitude of force F in Newton is. Okay, so we can solve this question by two methods, one by making component and one by using Lami's theorem. Let us try both method once. So if I let me assume that the force in the string, the tension in the string is T. Let me assume that the tension in the string is T, right? So okay, this angle is 30 degree, right? I can make two components of T. I can make two components of T. If I resolve T, this is T sine 30 degree and this is T cos 30 degree. T cos 30 degree, right? So what I can write it as F is equal to T sine 30 and 100 is equal to T cos 30. If I divide the equations, F divided by 100 is equal to, T will get cancelled out, it is equal to 1030. So F is equal to, what is the value of 1030? Let us see. 1030 is equal to root 3 by 3, that is 0.577 multiplied by 100. So it will become 57.73 Newton. 57.73 Newton. So this is the answer, required answer. So this is the required answer. Okay. In other words, I can also solve it using Lami's theorem. Let us try to solve this with Lami's theorem. Let's try to solve it using Lami's theorem. So in Lami's theorem, very simple. What exactly we'll be doing? This angle will be equal to 120 degree. How? Let us see. If you draw this, you draw this. You see this angle is 30. This angle is 90. So 90 plus 30 is 120. Right? Similarly, this angle is 150 degree and this is 90 degree, right? So how can I write the equation of Lami's theorem? Equation of Lami's theorem, I can write it this way: F divided by sine of the angle opposite to F, that is sine of 150 degree, is equal to 100 divided by sine of the angle opposite to 100, that is sine of 120 degree. So from here, this implies F is equal to 100 sine 150 divided by sine 120, right? So now sine 150 is 180 minus 30. So 180 means sine will be retained and minus 30. So sine of, I can say this is equal to sine 30. The numerator sine 150 is equal to sine 30. Sine 120 is 90 plus 30. So 90 means sine will change into cos. So divide by cos of 30. So ultimately it is coming out same 100, 10, 30. That is 57.7. I hope this question is also clear. So let us go to the next question, that is question number 10. Let us go to next question, that is question number 10. Okay. For the truss shown here in the figure, the magnitude of the force in member SR. So you are required to find out what is the magnitude of force in member SR. Required to find out what is the magnitude of force in SR. So we can approach this by two methods. As we know, we can solve questions from truss by two methods: method of joints and method of section. If I approach this with method of joints, I will first solve I'll solve for the equilibrium of joint Q. I'll find out what is the force in member RQ. Then I'll move on to the member joint S. Sorry, joint R. I'll move to the equilibrium of joint R, and I'll try to solve what is the force in SR. Right. So this is a two-step process. You can see first you have to find out what is the force in RQ. Then you have to move on to find out the actual answer, that is the force in member SR. So instead, if I do it with method of section, it will be easy. I'll be able to do it at one time. So I'll first try to do it if I can do it without calculating the reaction. So let me divide this truss into two parts by section the left hand side and the right hand side. The left hand side and right hand side. Okay. So in method of sections, I'll say that since the entire truss is in equilibrium, the left hand side should also be in equilibrium, the right hand side should also be in equilibrium. So I'll consider the equilibrium of right hand side here. Let us consider the equilibrium of right hand side here. So there are three members, you can see, four members. So this is force in member SR. This is force in member TR. TR. This force in member TQ. Right? Now, if you closely see, summation of force by, there are two unknowns. There are three unknowns here. There are three unknowns here. So it will be very difficult to do it without finding the reaction. Without finding the reaction, it will be very difficult. So I'll have to find out the reaction at point Q. So this is the vertical reaction at point Q. Right? So let us first find out the vertical reaction at point Q. Right? So this is the reaction, vertical reaction at point Q. This will be the vertical reaction at point P. Right? Now, for finding out the reaction, I have to assume the whole truss as one body. Right? Then I'll apply generally the equations of uh, uh, moment equations. Right? So the truss to be in equilibrium, the summation of moments across any point should be 0. So let me say the summation of moment about point P is equal to 0. Let me say the summation of moment about point P is equal to 0. So if I write down the equation, it becomes 30 into 2. You can see this is there are two forces only. There are two forces. If I'm considering the moment about point P, 30 into 2 meter should be is equal to reaction vertical at point Q, right, into 3 meter. So clearly you can calculate the reaction vertical at point Q. It is equal to 20 Newton. It is equal to 20 Newton, right? So this is equal to 20 Newton. Now, so even if you have proceeded with method of joints, you must have calculated the reaction. Without finding the reaction, you will not be able to analyze the equilibrium of joint Q. Now, about which point should I now take the moment of this truss? So if you see, I want a point where these two forces should cancel out. These two forces should cancel out. So if you see, if I take moment about point T, right? Point T, which the moment should be 0 about any point. So I'm taking about point T because first of all, I know the distance. I know the distance from the forces, and the secondly, and which is even more important, that you can clearly see that the two forces will actually pass through point T. The two forces will actually pass through point T, and that is why those two forces will cancel out. Those two forces will cancel out, and my equation will be very easy. So moment, summation of moment about point T is equal to 0. Let me say. So if you see both these forces now, which are the forces left out? SR and reaction at point Q. Both these forces are in producing anti-clockwise movements. Anti-clockwise movements. So I'll write down the equation as. How am I going to write down the equation? F SR into distance, vertical distance of SR from the point T is equal to 1 meter plus, I'm taking anti-clockwise as positive. Okay. R BQ into again 1 meter. Distance of point T from point Q is 1 meter is equal to 0. From here you can find out the value of SR. FSR is equal to minus 20 minus RVQ, that is equal to minus 20. So why is the minus sign? The minus sign represents that, it implies that the direction of FSR, what we have taken, is actually wrong. The direction will be towards right. The force FSR is towards right, and the magnitude of force is 20. So what is the answer? Answer is C. I hope you got all the concepts and you were able to solve from question number 1 to 10. Yes, I'll mention there is one question, I think question number 5, which is not from mechanics, so I have skipped that. Okay, by mistakenly, I have added that question in the assignment, but that question does not belong to mechanics, so I have skipped it. Now, if you are unable to understand any concept, right, please comment on the chat box so that I can make some detailed video on those concepts. Okay, thank you. Bye bye.